So far, we have taken a look at how we solve problems using simple sequential logic, that means one step of the other, something like area of a triangle, area and circumference of a circle, and so on. Now, let us say we want to take certain decisions. Like I said, if the age is greater than 70, we're providing 1% extra interest. For that, we use the decision making statements. But now, think of something like this. Let us say I ask you to print numbers from 1 to 3. So for that it's quite easy. You will just say, I'm not showing the complete work. You will say print 1, then you will write print 2, then you will say print 3. This is quite easy. But now if I change the problem and I say print from 1 to 10,000 or write from 1 to 10,000. Obviously, you cannot keep writing print 1, print 2, print 3, print 4 and so on up till 10,000. Computers provide you an easier way. What I can do is I can take a memory location. Let me give it the name I. Let me give it the initial value 1. So what I can say is I can say print or output I. So it will print 1. Now since I wanted to print up to 10,000, I should increase the value of I by 1. I say I is I plus 1. Now if I take this back here, what is going to happen? It's going to take print 1, 2, 3 all the way till whatever number you want. But there's a small problem with this. It does not really stop. It keeps on printing forever because there is nothing to tell it to stop. So in order to avoid this problem, what I can do is I can ask a question. Is I less than or equal to 10,000? I can ask a question. If it is yes or true, I can do something. If it is false or no, I can do something else. If the value of I is less than equal to 10,000, I can print the value of I. I can increase the value of I by 1 and keep doing this process till the value of I reaches 10,000. So this is an example of a loop or a repetition. In a loop or a repetition or a iteration, I am doing a set of statements multiple times as long as this particular condition or test condition remains true. Initially the value of I is 1. So 1 is less than or equal to 10,000. So what I am saying, it's true. I am printing 1. I am increasing I becomes 2. 2 is still less than or equal to 10,000. This is yes or true. So I am printing 2. I becomes 3. This way the value of I keeps going on. At some point of time I will become 10,000. 10,000 is still equal to 10,000. So this condition is true or yes. Then I print 10,000. I becomes 10,001. When I becomes 10,001, this condition is false and I will come and I will be required to stop. So I hope you understood what is the concept of iteration or loop. Without a loop, if I had to do, I had to keep writing print 1, print 2, print 3, print 4, print 10,000. Obviously, it's not a joke to keep writing print 1 till 10,000. Sooner or later, you are going to get frustrated and bored. But by having this process of a loop or a iteration, it's going to do it very easily for us. So what we shall do is we shall write a simple flowchart to print numbers from 1 to n. Now what is this n? N represents 10,000 in this case. So the user is going to enter the value of n. N sometimes can be 5, n sometimes can be 50,000, n can be 1 lakh, 10 lakh. Depending upon the value of n, you're going to keep printing the value of I. So if you have to do a flowchart, a very simple way of doing a flowchart is like this. So what I shall do right now is, let me keep some paper here. So let's try to take a look at how we go about doing this particular flowchart to print numbers from 1 to n. Okay. So the first is I'm going to say start. Okay. Since I want to print from I is equal to 1 to n, so what I'll do is I'll take a variable called I'll initialize it to 1. Okay. Since I'm initializing it, Okay, initializing it, you can do it this way or you can do it equal to, both are the same. Okay, so this is also initialization. This way if you do is also initialization. Let's be consistent. So I is initialized to 1. When I is initialized to 1, we need to know from 1 to n, but we do not know the value of n. So what I'm going to do is I'm going to ask the user enter the value of n. So when he or she enters the value of n, I know that I can start printing from 1 till n. Let us say the value of n is 100. So I'm going to print 1, 2, 3, 4, 5, 6 all the way till 100. Now, the first question you need to ask whenever you are doing a flowchart using a loop or a iteration, how long should this process continue? This process should continue as long as the value of I is less than or equal to n. That means when as long as I is between 1 to 100, it should keep printing. If it is true, what should I do? I should print the value of I. Okay, I should print the value of I. After I print the value of I, it is important that I increase the value of I by 1 so that it begins to print 2 next time. Now I have increased the value of I. The problem with this is either true or yes, and this side is false or no. If the value of I exceeds the value of n, then I can say stop. Okay, this is stop. Now I want this activity to keep continuing. So what I do is I draw a join here. Okay, I bring it like this and I connect it here. So this is the flow which is happening in this particular way. So what we'll do is we'll take a small value of n. Let's take a small value of n like 5, so that if it works for 5, it will work for any case. I is 1. I am reading the value of n. Let us say n is just 5. Now, is 1 less than or equal to 5? It is true. I am printing the value of I. So I am printing 1 on the output. I is increased by 1. I becomes 2. Now since I am going back here, is 2 less than or equal to 5? It is still true. So I am printing the next value of I. Okay, I is it's going to print 2 on the output screen. Here it's printing 2 on the output screen. I is increased by 1. I becomes 3. Again I go back here. Is 3 less than or equal to 5? It is true. I am printing the value of I, which happens to be 3. I am increasing the value of I by 1 here. So I becomes 4. 4 is still less than or equal to 5, which is true. Print I. It's going to print 4. I is now increased from 4 to 1. I becomes 5. Okay, keep track of this value. 5 is not less than, but it is still equal to 5. So we are still okay or true. I am printing 5. Now I ends up becoming 6. Once I becomes 6, you have to watch for 6 is not less than or equal to 5. So I will halt. So this is a way I am going to go about printing using an iteration or loop numbers from 1 to n. N can be 5, it can be 500, it can be 5 lakhs, or it can be 5 million, or any number. So this is how you go about printing numbers from 1 to n. Be sure you understand the logic. This is the start symbol, the normal rectangle box, reading, printing, decision box, normal processing box because I am doing a calculation, and I am finally doing a stop. So be sure you understand this kind of a logic.